guys like used IPFS in any capacity?
I'm gonna put a cat picture up there.
Okay, good.
That's what it's meant.
Yeah, yeah.
I'll try to,
Okay, that's helpful.
I don't know how to retrieve it now, but
Yeah,
I did it somewhere.
wise, that's funny.
Maybe another question too. So this presentation is going to be basically an overview of some of the underlying aspects of IPFS, and then I was going to look at setting up, a node just on your computer.
I found it interesting.
Yeah, okay, cool. Yeah, I think it's interesting too, because basically what we're talking about is essentially a new version of the internet, right? How nodes talk to each other on the internet. So just quickly, so IPFS and libp2p, those are two different distinct things, but IPFS is a big part of libp2p. libp2p is a library. Oh, thank you. Gotcha. Yeah, libp2p is a library that is probably if you're building something, probably that's the system that you're going to use because it contains a lot of other tools along with IPFS that are really useful, like IPNS, interplanetary naming system, and a bunch of other tools that are useful. So libp2p kind of came out of IPFS and is a little bit broader. So there's a distinction.
Yeah, a bunch of tools, just sorry to interrupt, a bunch of tools use libp2p, like Ethereum uses libp2p, what else? Like
Polkadot,
like
Bitcoin
everything. All
yeah,
the majors.
Polkadot, Bitcoin, I mean everybody uses
Most-
Or no,
I don't think Bitcoin does.
No, no.
I think.
Not anymore, no. They did back in the day.
Oh shit.
Yeah,
Oh, wow.
they used back then it was just IPFS. Okay, yeah, so content addressing versus location addressing. This is kind of one of the big aspects of IPFS in general. On the left, you have the traditional client-server model. We all use this every day. You've got a website hosted on a server somewhere. You go to hit that website, youtube.com, it hits the server. The youtube.com part, the domain name, travels from DNS, uses DNS to find out what the IP address of that server is, and then it'll return the content that you want. On IPFS, you're not asking the network for, basically you're not inserting a domain name and asking for to talk to a specific server. You're using that CID, the content ID, and you're basically just asking the whole network, hey, does anybody have this content, right? So you're not asking a specific server, you're asking the whole network. Really, you're asking your peers. We'll look a little bit more into this. So again, in location addressing, you've got Spotify.com, Google.com, NASA. Each one corresponds to an IP address. So if you've got nasa.gov/ some file, it's going to eventually end up at this IP address, and so you're actually asking for a location when you go from like a .com, usually. So that's kind of, again, the traditional model. IPFS, again, this represents like two nodes have one file, another two nodes are storing another file. Each node can be storing all kinds of different files, and you can also be a provider for that file for other peers. So totally different, again, that file only existed on that server in the traditional model. Now this file can exist like all throughout the network in a bunch of different places. So totally, yeah, different kind of, yeah. Good.
When I've tried to use like Brave to look at an IPFS stored website, it takes forever to load because
It
it's
can.
the latency
Yeah.
is like big.
So
Are there providers then that somehow speed that up so it has the
yeah,
look
there-
and feel of a traditional
yes.
site too?
Yes, so there's pinning services that will, I think, Firebase, or what is it? Yeah.
Pinata. So like
Pinata, yeah, there's different providers that will make sure that basically more DHTs are updated, or DHT portals, DHT nodes are updated so that the network knows where that file is being provided.
Knows where it is, it just get it there fastest. It's like,
Yeah.
so yeah, like if you're hosting a computer on just a normal internet connection, if you're hosting a file, sorry, it's like
Yeah.
there's a bottleneck there.
So it might take forever for you because geographically you're just not close to where that file is. Maybe basically like IPFS is way more efficient than traditional internet at scale when files are being requested a lot by the network, right? So if you've got some file that everybody's requesting, that's kind of when IPFS is the most efficient. If it's a file that nobody really requests very often, yeah, you might have to wait a little bit. Eventually, it should pop up. It can take a while though.
Retrieval times have been like going down a lot, like thanks to the guys like you, like getting the retrieval times down.
Yeah.
And
100%.
you should also look at it a little bit like, how is your data important, right? If you're hosting a website on the internet, and you're hosting it, like you said, on your computer, you're not really valuing your access to your
Right.
website you built, right? But if it's a high-profile website you want to host, you host it somewhere on, I don't know what cloud you're hosting it on nowadays, but if you do it on IPFS, it's the same way. If you're just hosting it on one node, choose that node well,
Yeah.
right? And based on access from somebody else, it gets distributed all over the world, or you can already pre-distribute it by pinning it on different locations, and then your access time is super fast. There's no.
Right.
So it
Do
depends
you
on how you
lose
set it up.
cost savings the more, is there like a threshold where if you have 10 regional parts of the world, then it's the same cost, is no longer cost
I think
savings?
It's modern web development, right? So like,
Yeah.
Similar, yeah.
right, so if like, just like to bring you to the real world, like a lot of people will be like, oh, open internet, open Web3, like it's all about getting rid of the big guys. And it's like, it's more you're better together. Like if you're trying to host something and you want 1 million people to be able to see it, where do you go today to do that? You go to Amazon. And like, I'm hosting a few IPFS apps. Okay, they're running IPFS. I'm supposed to be Web3. Where do I host them? I host them on Amazon. Because Amazon's the cheapest. My cloud is cheaper than probably most people's. It's like energy-wise, like it's all about physics. Like how much energy is your system running? Well, even if you're running on Amazon, it can be really low, no matter who your provider is. It can, as long as you're smart. And so, using Amazon's great. Using Google, great. Whoever you want to use, 10 out of 10. But whenever Amazon goes down, is your system, can you move it to a different one easily and still run it? That's the question. And so like you have to build like modularly and
Yeah.
Yeah, you see a lot of those models, like hybrid models. Seen a lot of people hosting it, for instance, in their own data centers, spread out over the world, and they have like a backup IPFS node running in
Yeah.
AWS to back it up in somewhere else. I don't know. It's a mix of. I don't see Web3 existing without Web2
Right.
in the future. That's just not happening. But Web2 will definitely need to change, because you can see that Google, Amazon, Microsoft, they're even reaching out directly to us to have that conversation on how do we educate our Web3, because everybody has a Web3 team, right? They all have it. You can maybe they won't admit to it, but I can assure you they have it. And they're all reaching out to these bigger crypto players or blockchain players to have that conversation on how is Web2 and Web3 is going to look like in the future. Because they,
Five.
I don't know.
Yeah, that's the thing. Is like people from PL, like I've had this conversation with people from PL. I'm like, oh, that's not Web3 enough, and they're like, Logan, there's no such thing as Web3. It's really like, is it open? Is like with the data you're looking at, is it open data? Is it open source? Like, so it's more about the open web. It's like that was a big realization for me. I didn't really realize that until recently. It's like Web3. Who knows what that is?
Yeah.
What's Jack Dorsey's company? What is that called?
Blue Sky.
Web
Oh,
five.
Web5.
Web5, yeah. It's like, who came up with that? Who was skipping force?
It's Web 2 plus Web 3.
Yeah,
There you go.
that's how I
There you
got to
go.
Web
That's a good
five.
answer. That's a good answer. I see always Web 2
Yeah,
and a
I
half,
don't know.
so maybe I should go for
I like
Or
the.
maybe it's Fibonacci webs. The next web is going to be Web 8.
There's some really cool new like I like Kubernetes, again, kind of like pretty traditional and like Docker containers. You can even set up different Kubernetes nodes on different hosting providers around the world, and they can all, you know, be load balanced for the same network. And now there's like, I think there's really cool, basically similar to Docker containers and Kubernetes nodes that are all WebAssembly based, which is really cool. So like WebAssembly, I think, WebAssembly, Filecoin virtual machine that talks to Ethereum, or any EVM chain, like that is going to be really interesting. So yeah, this, you know, the
Is
whole
that live?
Yes, yeah, all of it. Yeah,
Launched
there's
some Pi Day, like 2 days ago, 3 days ago.
Oh, cool.
Like literally.
Yeah,
There's
yeah,
actually one thing
FVM.
that I wanna add, like on the slides, you saw FVM, which, right, is the smart contract way of doing on Filecoin, the same as Ethereum does. And you mentioned, I think, the Saturn network, which is the CDN network. The third player that I'm missing there is the compute over data part, the Backlio team, because Filecoin is into moving, like, we have this vast amount of data everywhere, right? And then what we wanna do with compute over data is that you can, like, do computation locally on the data, like at the data edge. And the big difference there is, like, in the cloud, you need to move it all together, which is very expensive to move it, just the egress and moving it between zones or whatever you want to do with your data, move it together, do that computation. And then when you have that data coming out of that computation, you need to move that again, which is also costly. While when we do compute over data on the Filecoin network, it's done locally, the result is kept locally, it's stored locally, and you just only see the actual result, which is minimal amount of like data moving around, so that
Yeah.
one should be added.
That's
Like,
man,
Definitely, yeah.
that's like holy grail. If
Yeah.
we get to that point, which yeah, pretty
Yeah.
soon. I mean, yeah, there's no comparison between Filecoin to, you know, traditional web. So distributed hash tables is a pretty interesting concept. First of all, IPFS, when we think about IPFS, there's IPFS, the public network, right? And then there's IPFS, like you can run your own private IPFS implementation, right? We could run our own private IPFS network that just, you know, has everybody in this room. That doesn't necessarily talk to the main implementation of IPFS, right? If we were to do that, we would need our own distributed hash table, which is basically just a database that every node in the network has the same database. It's a key value store. You know, I'll just read this. Distributed hash table is a method of mapping keys to their associated values. They're fundamentally databases of keys and value pairs that are split across the peers. Basically, every peer is supposed to have the same records is the ideal situation. In order to upload or retrieve data stored in IPFS, there must be a mapping of each node's peer ID, that's the key, and then the content identifier, that's the value. In the peer that the peer is storing, the DHT maintains this mapping of each CID with the peer ID of the nodes that are hosting. So DHT tells the network who has what files on the network, right? And so you think about, you know, peer-to-peer network, I spin up a brand new IPFS node, and then I get all these peers. All of a sudden, my hash table is, like, let's say I request a file, or maybe I upload a file, and that puts a message out to all the other peers, hey, I have this file, right? And so all the nodes are basically doing these have-want communications all the time. I have this file, and not just I want this file, but maybe the peer I just talked to is looking for this file, right? So there's different algorithms, and we'll talk about those in a second, of kind of how these peers talk to each other. But the point is, they're storing this data on the DHT, which again, basically a database that every node has, and the idea is that eventually every peer in the network is going to have the same entries in that table, right? So that's the idea, and again, the main IPFS implementation is going to have its own DHT. If you started your own private implementation, it won't include any of those files on the main one. Yeah, again, this is pretty interesting. So just kind of looking at this flow, you know, user request to CID, that kind of starts the process, starts with the request. You search your local node first for that CID. If you found it, great, you have the file. If not, you broadcast to the network this want have to all of the peers that you're already talking to. If you haven't received a have response yet, then you basically search the DHT for who may have that file, and you can actually, you know, if there's an entry in the DHT that has the CID and the peer ID, I could go and contact that peer directly. Like maybe I'm not already peered with that node. I can just go and become a peer to that node, and if they have the file, then, you know, establish the connection or receive a have response, and then and then basically I'll eventually get the data. It also send a want block for CID to some peers in the session. So if I have let's see, add have sending peers to session, yep. So I add that peer to my session, send a want block to that peer, and then I'll get the data back. If you don't get, for some reason the DHT is wrong or that peer is offline, you'll kind of get this idle loop, and that's where it can take a while. It'll keep searching through the network until it finds somebody with that file.
It times out.
Or the request will time out. Yeah, so that's an option too. It's not 100% foolproof that you'll get a response.
I'm sorry, where did you get that,
That flow?
where the hell did you find that, where did you find that? Or did you make that yourself?
No. Usually I have a credit on here. Just Google.
Launchpad website, I think.
Yes.
Launchpad,
I think
okay.
so, it's on there.
I've never seen that, and I wish I
I
had.
think it's here, actually, file base.
And Filecoin has it.
Yeah.
Thank you.
Yeah.
That's very good.
Cool. So discovery algorithms, these are pretty interesting. There's again a couple of different ways that the IPFS nodes can kind of talk to each other in order to actually find the file that you're requesting. And I've talked about these before, but little quick refresher. So gossip sub is really one of the main ones. Every 1 second, each peer randomly selects 6 metadata only peers and sends them a list of recently seen messages. So this is, again, they're talking about gossip. It's called gossip because you're essentially saying, you're talking about what other peers have basically been asking for and what other peers have. So you're not necessarily regarding yourself, but you're just kind of picking random, a random set of peers and kind of gossiping about what they have. And if everybody's doing this all the time and it's random, eventually, hopefully, you get a mapping of who has what for, you know, everything that people are requesting in the network.
This like gossip sub is like if you wanted to like, what do I use gossip sub for? Apparently, like a few years ago when they like first built this, it was like the best protocol for a chat service. So like
Well-
gossip sub can get a message broadcasted throughout a whole network and like it's faster. It's like super efficient.
Can be, yeah. So gossip, that's like gossip, again, it's nice to subscribe to, you know, like a channel or a topic, and we, I think one of these goes into that too. So these are just, okay, so there's metadata only peers, and then there's full message peering. The metadata, again, might have just information about the network, about who's storing what, whereas there might be, you know, peers that actually have the full data, storing the full data. Again, that's using gossip sub. So again, reading this, the peering degree is we call it D, controls the trade-off between speed, reliability, resilience, and the efficiency of the network. The higher peering degree helps messages get delivered faster with a better chance of reaching all subscribers with less chance of any peer disrupting the network by leaving. However, a high peering degree also causes additional redundant copies of each message throughout the network, increasing the bandwidth. Yeah, so again, all of these discovery algorithms of how the peers talk to each other have, pluses and minuses to them. They kind of each different algorithm are better for different use cases. And actually, if you look at PubSub, which I think PubSub is actually used for chat more, because your chat room becomes a topic that everybody subscribes to, right? So if I only care about the topics going on in this chat room, I can, basically subscribe to actions that happen there, and when an action, like event sourcing, when an action is published, because I'm subscribed, I get notified, so kind of like a webhook. So you can do this around different topics, and maybe I don't want to sync everything in IPFS. I just care about these specific things. So that is another way to be more efficient about what you're syncing, what you're peering. Graph sync is, I think somebody brought this up earlier. Maybe I don't need the entire piece of a file. Maybe I'm just looking for a specific part of that file. If I actually know maybe I just need a value that's stored on a form somewhere or something. I just need these little bytes of a file. If I know that, I can call that CID directly and just sync maybe I just need this folder in this larger folder with all these files. So I can just call this CID and just sync this part of the graph. I don't need to sync the entire graph. So again, another algorithm that you can implement just to be more efficient with what data you're actually storing. And again, also because I only requested this piece, I'm only going to be a provider for this piece. So maybe I'm geographically closer to somebody that's also requesting that. I can return this chunk to them, but they'll have to get the rest of the file or the folder or something from somebody else. But it, can be more efficient. Okay. Installing, so let's try this live.
Does anybody run IPFS at home on their computers? Anybody?
So you gotta connect to the Wi-Fi, or you gotta connect to my hotspot.
Do you run
I
a
like
storage
storage.
node? Do you run the petabyte server?
Do you
He
have?
run, not only a local node, which
Yeah.
is just what I run. Okay,
Yeah,
he
swipe-
runs an
swipe
actual
over.
Lotus
That
node.
must be
Yeah, just do a new terminal.
thousands of dollars of storage.
It's 2 petabytes.
It's Chrome.
2 petabytes. It's
You're good.
$50,000.
Depends on where you bought your drives, right?
Well,
Is your drives used or they new?
well, for a 2 terabyte NVMe 980 Pro,
Okay, we're not talking
It's-
about SSD.
If you just
right?
go like this, you'll get the Windows.
he's spinning less.
Or if you swipe.
Most
They
Filecoin
use
is
for long-term storage.
Just do a new
it's
one.
spinning the drives, and then for the ceiling pipeline is whole enterprise NVMe, those grows
If you have 2 petabytes of SSD, of NVMe SSD, you're Cloudflare.
Well, you could have petabytes of RAM, right?
Petabytes of RAM?
Yeah.
A petabyte of RAM?
I wanna know what your hardware.
Exactly, right?
If you, I don't even think, I don't think that there's really many
You
computers
can
with
have,
petabytes.
there's computer configurations that exist that allow you to get a terabyte of RAM.
Oh, yeah.
Oh yeah, I've seen those.
I have
Yeah.
a-
So you
I
can
have
just
Kubo running on this.
NVMeify.
I didn't realize, I didn't see your message.
Okay, let's do
So
the
dense
easy,
yeah.
let's
or
do the
regular
easy
dense.
way. Hold on.
And then you get
I
some
just thought about
The
that.
only reason why you ever use a terabyte of RAM is for a RAM disk. You're using.
Or
my
SAP.
machines have 1 terabyte
What do you need?
memory,
Looking for.
because else the ceiling pipeline won't.
Are you running a data
Did you
center
club?
or something?
It's
Definitely, no, if you didn't know, this is Angelo from PowerPoint Foundation. Or you're not even from PowerPoint Foundation.
No, I did this before I started working.
Okay,
Right, yeah. Yeah, Fortinet. You work for Fortinet.
I
Yeah.
used to work for 40 years.
Yeah. Yeah, so most of it is all, by the way, I wanted to know, what specific program do you use?
So-
I use I replace everything by what is it? It's the old IBM, the Toshiba ones.
Okay.
There used to be
Which one? What time you got?
HTST drives on IBM.
14.
Toshiba
Days,
is
12
14.
days.
Alright,
No,
we
we
got
have 15 minutes.
Alright.
18. Oh, wow.
Cool guys, so we've got like 15 minutes left. I was gonna go through the process of installing Kubo, which is like basically a light node that you can run on your computer. I'm actually just gonna do the desktop version, which is, you know, if you're not familiar with like terminal command line stuff.
Or do you want to use my Kubo node and just like pin a file or something?
No, I kind of want to show the interface.
I feel like I think 95% of users on IPFS with nodes running are using the IPFS companion.
Yeah.
And so if anything, maybe download.
Companion's running right now. My node is running.
Oh, this companion app up here.
Right there, yeah. If you just click that.
Is this it?
Yeah,
Yeah.
my node.
Okay.
Yeah, good call.
Yeah. Okay, cool. So like, this is kind of what you'll get either if you run Kubo or if you download a DMG or a exe file of the desktop version. You get this cool interface that will show you all the files that you pinned or that you uploaded. You can see the peers on the network. So we just connected to the network.
This would be
Pretty cool. I'll show you guys a couple other things that you can. So yeah, this actually shows you bandwidth.
Yeah, sorry to interrupt. I have to interrupt.
Sure.
So the guy who works on this, his name is Russell Dempsey. If anybody loves UI stuff and they work at all with React, anything UI, you can go to GitHub and help Russell, or Sergeant Pookie is his name on GitHub. You can help this guy with a ton of the problems with this thing. And so the IPFS desktop, it is like 4 or 5 years old, and it's like last year they actually got somebody really good to like fix a lot of the problems with it because it was built on Create to React app, which if anybody knows what that is, like building something for a lot of people to use on that is probably really bad. So yeah, this is really cool to like be able to mess with this. Like you could push an update on this yourself right now, and everybody, thousands of people would see it. So this is a huge low-hanging fruit. If anybody wants to work with PL on anything, this is a big one. So.
Yeah, and here's like some of the things that you can do with these. So you can actually pin your own files. Also on Kubo, you can set your node as either a server or basically just a client. The server version is meant to not be turned off. Most people are probably running just the normal client version, but you can pin, you know, again, it won't be available if you turn your computer off, but you can pin your own content. You can download the CAR file, the content archive file, which is kind of cool. You can also publish to IPNS, is kind of cool. So if you've got an IPNS gateway, which is, again, kind of similar to DNS, basically it's a way to take, let's say, like a domain name or even a CID that somebody would use. You can actually point that, kind of route it through DNS so that CID points to always like the newest version of the file. So even if the CID changes, you can, you know, keep this same CID that kind of everybody has already and make sure that they're still seeing the newest version of the file. So you don't have to constantly update the links every time you change a file, right? Yeah, so that's pretty useful. Again, you can set your pinning service. You can do other things in here like set which gateway you want to use. Right here, public gateway. So Alex is using IPFS.io. You could use like web3.storage or any of the other gateways.
Can you create a custom share link?
You,
Yeah, that would be like a subdomain. of-
well, you
under an
can
existing-
always, you can pretty much always like use like a traditional DNS or DNS, like buy a domain, you know, set up some DNS rules and just point that DNS to your IPNS settings, or basically you copy some IPNS settings to your DNS settings, and yeah, point the domain to an IPFS file. Yeah, it's
Yeah.
something a lot of people do. Just you've done it, right?
Yeah, like, it's really hard to like really show like, okay, this is a really good use of IPNS, but we have like a particular example that's really amazing. If you're doing a link tree on IPFS like we are, every user has a link for their IPFS page. Okay, so like here is an IPFS page. It's your page. It's got your name on it in whatever links you have. So that's a CID when we first created it. So when you go and you put new links on there, well, it's IPFS. You've got a new CID now. So all your friends are going to a different link. They're going to your old link, and so now you need to update it. So IPNS, it was a huge update for us to where it's like, okay, now all of our users have an IPNS name that's mapped to you, and then we will update. We'll keep track of what needs to go there. And so like IPNS is like there's not very many apps that use it, but like that's to be using IPFS is one big infinity stone. To have IPNS working on it is like, okay, there we go. That's a whole nother deal too. So
Yeah, just like DNS to the internet. If you didn't have DNS, you'd have to type out the IP address of all the servers that you're trying to talk to. Yeah, just makes it easier. It's really helpful. But yeah, that's all we have right
So
now.
that website that Angela was talking about is filecoin.eu, right?
Yeah, yeah,
Should we check it out for a second?
sure.
Yeah?
You can.
Okay.
I would go to the calculator, maybe it's more fun to look at.
And then so without IPNS, it's like if somebody clicks on the link that used to be valid that's been updated, it's like they're just seeing a previous version.
Exactly.
Versioning, it's like
Yes,
a crude
previous
version
version.
kind of,
right. So like
and they don't even know that it's necessarily an older version. They just go, oh, here's the data that I
right. So
clicked
like
on that link, and that's what it is.
yeah, I would log into my open links and I would change my links around because I got like a cool new link, and so then I would have to go and update the old link on my Twitter. Whereas now, the link doesn't change because it's mapped to IPNS.
Right.
I would go to calc.filecoin.io.
Oh, okay.
So how is this hosted?
Oh, okay,
It's
cool.
not IPFS.
Nice, good.
So that's the new ROI calculator for storage providers that will come online in 2 weeks.
Nice. This is awesome.
Yeah, so this is like
Some alpha.
this is so new that the PL network doesn't even have this.
You guys are really getting a sneak preview
Yeah,
here.
this is announced on all hands 2 days ago.
Super cool.
Worth the price of admission right now.
There you go.
Yeah, exactly.
Very cool.
18
So you build
months.
stuff
That's
before.
awesome. Yeah.
So you can play around with it.
Nice.
It's like the second bar is very interesting. That's the amount of
Yes.
verified data that you'll
Right.
be doing.
Right. So like, if you weren't storing any real data, you were just doing committed capacity, like you're underwater. Already.
How do you get to an 18-month of like 100,000 or something like that?
I mean, you've got to be storing real data with Filecoin,
Yeah.
Filecoin Plus, right?
Yeah.
This is basically the Filecoin
That's
Plus.
I would recommend that definitely. I mean, there's two very like key indicators there. When you look on the impact on earnings section, you see that the average Filecoin per block is like 17 right now, and the Filecoin price is apparently 5.8 right now. Just
Yeah.
pulled it through the API.
Oh, cool, nice.
So these two you can play around with, but looking at the future of the network, as block rewards will decline. That's inherently how the protocol
Does this
works.
tool take into account the block reward declining?
What it does right now is that it will let you play with it. The tool works on what the situation is now, and it will take in somewhat of a decline, but I cannot predict the future because the decline or how much it will decline depends on the baseline minting. If you want to get into that, we need a whole new session.
Yeah, I know.
Maybe next month we
Seriously.
can dive into that if you want
Yeah.
to.
Well, you don't know, like, the next halvening is gonna be
No,
in 6 months.
No, that's based on the raw capacity of the network.
Okay, so it's a function of the network
Yeah,
effects?
yeah, the protocol keeps track of that, and that's built in since the beginning.
And what is it, like every 30 seconds there's a new block?
Every 30 seconds is an epoch. And,
It's an epoch.
Yeah,
There you go.
and then,
This is awesome, really cool tool.
How
Yeah.
much, what's the
We've got on
infrastructure cost to create that
6
setup
minutes.
right there?
oh,
minutes.
if you
Yeah.
scroll down
Let's
to
get a
it,
picture.
the CapEx.
Yeah, yeah.
It's like,
down
you wanna
to
put your
it.
slides up again for
Yeah,
good
you can
background?
scroll, if Dante can scroll down.
Yeah, scroll down, Dante.
That's a basic setup for 1 petabyte.
That's not bad.
It's not bad at all.
That's not bad.
Wait, how much?
156 grand.
156K.
That's when you
We'll
run.
break
it.
even in a year and a half, no problem.
Well, really not bad when you consider, like, okay, so this is the collateral needed.
Yeah, that's.
Right
different.
now,
Yeah.
that's not that much money. When I started Filecoin mining, I mean, I think Filecoin was at like $100 or something.
Yeah,
So
that's
this kind of collateral cost a lot more
yeah,
back then.
I know.
You could
Well,
Okay.
Take all that money out of the HELOC before they freeze the credit lines.
Yeah, there you go, exactly. Cool. Yeah, so we got 5 minutes. They're gonna kick us out, but we'd love to get a picture. If everybody can,
Oh, wait.
Definitely.
if you want your picture taken, come up to the front.
Does anybody know what the picture taken?
Dave,
Yeah, who doesn't want the picture taken?
you want your picture
Yeah?
taken?
Would you mind taking a picture for us?
Yeah, no problem.
That's a perfect job, right?
Yeah, there you go.
Cool, it's like,
Hey, I already talked to Grady, he wants to meet you guys. If, I mean, obviously, it's totally up to you if you guys wanna, like, do everything.
Videographer.
And it's a
Oh,
sweet
nice.
place.
Thank you so much.
Thank you, I really appreciate it.
Brandon, nice to meet you, Dante.
I just tried out water.
Yeah.
On this.
Anyone else?
Take it from me.
Proof of attendance here?
Proof of attendance.
How are you gonna get your proof of attendance, NFT?
Yeah.
Anyone else?
It's our NFT.
Anyone else? Alright, here we go, and Filecoin.